Okay, Year 10, so welcome to question 1 of lesson 1. I've had a few requests from some of you to help with how to do the questions. So here's a video to try and explain the finer points. And in question 1 it says figure 1 shows a boat floating on the sea and the boat is stationary. It says figure 2 shows part of the free body diagram for the boat. Complete the free body diagram for the boat. And the idea here is the boat is floating on the water, so the forces acting up and the forces acting down must be exactly the same. Like that lesson I did when I had a stool on the table and told you the stool couldn't move up or down. If you take the force they're showing, the weight of the boat acting down, it looks like it's 5 centimetres, and I'm going to go with 5 centimetres. Equally, look how nice my ruler is, and that's a lesson for some of you who have terrible rulers for this sort of work. I therefore need a force acting up 5 centimetres, and in the exam you must do this with a ruler, and you must do this as neat as possible for them. Now when you were doing the questions for me you were unable to do that, and I accepted that because you were doing it freehand straight into OneNote, and the line up should be 5 centimetres, and the line, so I've made mine slightly too big in my opinion, but so if I say there, accept my correction, and then you've got the two must be the same, and that's your answer for the first part. All it requires is that. Now a word on there that helps: up thrust. If you don't know the word up thrust, will you please learn it now? Over we go to the next question, and the next part: calculate the mass of the boat. Use the information given in figure 2. Now figure 2 was this up thrust business. They're telling us the mass of the boat, or telling us the weight of the boat, and here we have the information that 1 centimetre is equal to 5 kilonewtons. Now when I measured this a minute ago I said to you that's 5 centimetres, and therefore it's obvious to see 1 centimetre is 5 kilonewtons, then 5 centimetres, 5 times 5 will give me 25 kilonewtons. The trick there, it's in kilonewtons, and you've got to watch the units when you do these questions. So come to the question. It says calculate the mass of the boat. Use the information given in figure 2. We already know that it's 25 kilonewtons, and I like to write bits and pieces on these questions to help me whenever I can. Gravitational field strength 9.8 newtons per kilogram. So you notice here straight away that's in newtons and that's in kilonewtons. One or the other's got to change. There are 1,000 newtons in a kilonewton, so it's fairly obvious that this is going to be, my thinking is that's going to be 25,000 newtons when we come to do the question. The last piece of information we've got to bear in mind and give the answer to 2 significant figures. So how do we do this question? Well, we're looking for Newton's second law, F equals ma, or in this case F equals mg. If you read the chapter on weight and mass in the textbook, you'll have come across this relationship, that force acting down is equal to your mass times the gravitational constant of the Earth. So what do I know in the question? In the question I need to know the mass. The force, I do know the force down, it's this thing, 25,000, so I can write 25,000 equals the mass I don't know times 9.8. Now I say again to all of you, particularly boys who tend not to put the working out in, they like to see the working out. They are offering you 4 marks this question. They want persuading that you're worth the 4 marks. So that's my basic equation. I've got to rearrange this. I've got to have m on its own, and again this can cause problems for some of you, and I go back to this idea I've given you many times where we do the cross arrows across the equal sign. If you look at this equation here, everything's at the top. If I put my arrows in, it'd be like this, like that. I need to get the mass on its own. It can stay there. I'm going to move the 9.8. The 9.8 will follow this arrow down. It goes down like so. So it ends up downstairs. So if I rearrange this, 25,000 over 9.8 equals m. Hopefully you can see my scribble there. So out comes Mr. Trusty Calculator, and on we go with this. So 25,000, I'm going to divide that by our 9.8. We get 2.551 dot, we get 2,551 dot, it's confusing, isn't it? 0.1, and it says to 2 significant figures. And so in my question here, I therefore need to take the answer I've been given off the calculator. Let's write this down: 2551 dot point 9. Sorry, point 1.02. Because I'm trying to look at my phone at the same time as I'm looking at the equation. So let's put those numbers in. It says to two significant figures, so I can only have the first two figures. So I've got to get rid of all of these by rounding up. My decimal point is there, and therefore I'm going to have to round this up to become 2600. The mass is 2,600 kilograms. And you put that answer down there. Now, I'll tell you now, another problem I come across in these questions for some of you lot is you'll do this sort of working out like I've done, and you'll leave it there. And the answer's like up there somewhere. You never actually put it into this bit down here. Now, what I've done here for my 4 marks, have I done enough for my 4 marks? I've converted kilonewtons to newtons would have been one of them, and I've spotted that. And doing two significant figures is that bit there. That's the second mark that are given. And then the third and fourth marks went for rearranging the equation correctly. Had you used 4.9, not 5 centimetres in the original figure here, because you measured it slightly shorter, that wouldn't be a problem. They wouldn't hold that against you. And then it comes on to the next bit. So the boat pushes the water backwards, the boat moves forward, the force on the water causes an equal and opposite force acting on the boat, which law is this an example of, and this is Newton's third law of motion. That's why the boat stays where it is. And you write it out like this, and that's that mark gained. So we then go on to D, and we have the boat pushing a small dinghy, and the tension force in the tow rope causes a horizontal force forward and a vertical force. So the idea here is there was a force like this, and there was a force like that. Horizontal force upward is 150, and the vertical force, the horizontal forward is 150, silly me, and the vertical force upwards is 50. So therefore we come to something we've done a couple of times in the lesson. They love these things. And they say draw a vector diagram, we're here, to determine the magnitude of the tension force in the tow rope and the direction of the forces caused on the dinghy. And so it's worth 4 marks. So it's 4 easy marks, this, if you do it correctly. And the vertical force upward is 50, and I've got to have a nice scale to this. And I mean, I can do this very, very small and just use one of these big sections for my upward, and so that's 50. And I draw a straight line. This must be done with a ruler in the exams. Please do not ever try and do this freehand. They will not award the marks. Then 150 would be 3 lots of those blocks, because that's 50 and that's 150. So I'm drawing a scale diagram. Now, just like we've done before in the class, complete the parallelogram. Now, I'm going to do it with dotted lines. Now, I'm just doing this for your benefit so you can see it on the camera. In the exam, you can just do this straight away with easy straight lines. It's fairly easy, these, to see where the resultant force will go. But to make my diagram complete, the exam board's demand, you put the arrows on. You must show the directions of the forces. My resultant, therefore, has to come across this here. Like so. You do it as accurate as you can, and you pop it on there, and you put it in, and you must put the arrow on that. So your resultant force to scale is going to be this length here, and you take this down, you take your ruler and take accurate measurement off there, and here I'm coming up with about 5.8. Yeah, about 5.8 here. And then my 5.8 on there will give me, if I multiply that up, it will give me a reading of about 158 as my force, my resultant force here. An alternative way to do this and is to use Pythagoras, because this is clearly a right angled triangle, and that's the hypotenuse, and that's also 50 if that's 50. And you can say the resultant squared is 50 squared plus 150 squared, and if you resolve that, r equals the square root of 50 squared plus 150 squared. Do it correctly on your calculator, and r will come out, I believe, at 158 again. And that's the other way of doing it. And a lot of students do that in the exams to save the worry about have you missed the range on this, or can you not do the scaling. Worth doing that. So I'll write down here 158. You then get your protractor and you place on here, you want to know this angle. You can do that angle, but you just got to, it's usual to do this one. And this works out to about 20 degrees with a protractor, which I have actually forgotten to get for the purpose of the video. But you get the idea. That's how you do the question. That's another easy set of marks. So we move on to question 2. Momentum's a vector quantity. And so, how is a vector quantity different to a scalar quantity? Vector quantity has direction. Now, when I'm marking exam papers, you'd be amazed the number of students just write down the word direction. I like to write a sentence. Be clear about what it is that's got a direction, unless you're really pushed for time. And then name another vector quantity. There's many you can choose from because momentum is mass times velocity, so therefore velocity should be a vector. Well, that'd be a good one to use. So I could put velocity in there. And I think the mark scheme gives a few of these. And you have force, that's another one if you wanted it. Weight, we've just been talking about, the weight of the boat, as another one. I've only asked for one, but I'm just giving you a handful to remind you. Definition of momentum is very simple. It's mass times velocity. And you write it out like that. That's what they want. And the unit of this, well, that's simple enough. The unit of mass is a kilogram, and velocity is meters per second. You either do it like that, or you can have kilograms, meters per second. Either way is good, but that's your unit of velocity. So far, that's some lovely easy marks for the momentum question. On we go. Now we come to this one. The image shows a golf club about to hit a stationary golf ball. And it's the golf club is in contact with the golf ball for 1.8 milliseconds. So watch that, because there's a conversion job to think about. Exerts a force of 1500 newtons, that's okay. And the mass of the golf ball is 0.045 a kilogram, that's right. Calculate the velocity of the golf ball is a golf club. Now you need to get an equation from the book for this. And so just to make it clear where this stuff comes from, why it was important to do the work I set on the run up to Easter. Just to show you where this comes from, this is 10.6 impact forces. And it shows this piece of work here about impact forces. And it actually derives this equation for you, that it tells you here that force is the mass of the object times its change in velocity. Delta V, this funny little triangle V, means there's two velocities. Normally there's a starting velocity and an ending velocity. There's a time taken. That's in seconds. Immediately tells you there's going to be a conversion in this. So let's write my equation down. You can get this from the equation sheet, but you'd have to know which one you're going to use. You have to be able to do this. So force equals my mass times a change in velocity. And that's normally v minus u. Final velocity, initial velocity. The initial velocity of the golf ball is 0 because it's standing on its tee, and it's going to go off at a certain speed divided by time. I know that's going to be 0, but let me put all the figures in now so you can see how this is built up. So I've got to carry the velocity of the ball, so the force is 1500, that's simple enough, equals the mass is 0.045, that's simple enough, times, now the change in velocity is v we want, and 0 is not there. I've got a feeling the mark scheme for this question actually has this printed wrongly. Divided by time. Time is 1.8 milliseconds. Now 1.8 milliseconds, you've got to bounce the decimal point back 3 places. 1, 2, 3. So I do it as mechanically as this, so I never get it wrong. 1, 2, 3, because it's very easy in exams to get this wrong. So that time there is 0.0018 of a millisecond. It helps you to see how I do this. I'm thinking this through myself. Well, I've now got to rearrange this big equation, but it is going to get me 4 marks, so it's worth doing. I'm going to just put this down now. I'm going to have 1500 equals 0.045 now times v, because the naught goes, divide by 0.0018. We have to rearrange this thing. And so therefore, and I've taken my dividing line too far across, but that's partly to show you the ups and downs again. Really, let me be quite accurate with this. I'm going to put my 0.0018 there. I know it looks a bit of a mess, but you'll see the idea. Now I'm going to cross my arms again. It's this business. Do this again. I've got to swap this round. It won't be on its own. So the 0.045 goes across the equal sign, but it's going to go downwards. The 0.0018 is going to go across the equal sign. It's going to go upwards. It follows the arrows. Remember this piece, please? So therefore, we're going to have 1500. That's going to go up times 0.0018. Divide by, that goes down, 0.045 equals my V. Well, let's find out what that equals. So it comes back, Mr. Calculator again. And we have 1500, you still see that, 1500 times 0.0018. Just like you, we all make mistakes sometimes, so 2.7. Be careful with your buttons. Divide by 0.045 equals, and it comes out as 60. It sounds like a nice number. So it's 60 meters per second, and that will get me my 4 marks. Okay, everyone happy with that one? It's a higher question. And then finally, when hitting the golf ball, the golfer swings the golf club to keep it in contact with the golf ball for as long as possible. The force acting on the golf ball is constant during this time. Explain the effect that the time of contact between the golf club and the golf ball has on the distance the golf ball travels. And so therefore, the way this goes is the longer the contact time, and that's a greater momentum. And momentum. Trying to get 4 marks here, remember. So what else do I know? So the velocity of the ball increases. And why is that? The mass of the ball is always the same. Okay. And then the velocity of the ball, therefore the velocity must increase. Because something has to give. And finally, therefore, you get an increased distance. And that's a sort of way you're going to get your 4 marks to complete that question. Now, the hardest part in that question was spotting the equation needed for this, which is on the equation sheets and is in the back of your book. But it also reinforces the need that you have done these chapters. And I cannot emphasize this enough. The impact forces, it's higher. At the moment, all of you are down to think about higher. You might be doing foundation exams, but it doesn't mean to say that's where you're going to stay. And therefore, it's beholden on you to understand this. This bit here explains where they get that from, if you're interested. But that's not to learn one. You'll always be given that in exams, in my opinion. But have a go at that sort of thing. And if you didn't understand that chapter, go back to it. Okay, thank you very much.